Thank you for tuning in today. We are very excited to having you join us. My name is Dalton Hesley. I am a senior research associate in Dr. Diego Lehrman's Coral Restoration Lab at the University of Miami's Rosenstiel School. So today I will be talking a little bit about our ongoing coral research, our active reef restoration, as well as our Rescue a Reef program, which is focused on citizen science and social action. So we hope that this is an informational talk where you learn about all the above and end up inspired on how you can support our coral conservation and restoration activities. So without further ado, we will start with coral reefs in general, commonly called the rainforests of the sea because they are incredibly biodiverse ecosystems. So they support a vast majority of marine organisms in unique ways and are one of the few ecosystems in the world that have these same qualities. So we start there just to emphasize how really rare, unique, and important they are for us, as well as the organisms that depend on them. So looking a little bit more specifically at the roles of coral reef, here is a relatively brief list. So we start with coastal and storm protection. Many people don't realize this, but coral reefs actually absorb up to 97% of offshore wave energy. So they're really our first line of defense, whether that's a tropical storm or Cat 5 hurricane. They really protect us day in and day out from that offshore wave energy. So it's really important to have these in these coastal communities to ensure the safety and security of our friends, families, neighbors. Next, more commonly well understood, is their habitat. So coral reefs are home and habitat to many, many marine organisms. In fact, 25% of all marine life rely on coral reefs at some point in their life cycle. So that is an important ecosystem for them as a whole. Next, that equates to food. In fact, over 1 billion people on this planet rely on marine protein as their main source of food. So without coral reefs, that would put their livelihoods at jeopardy. And then all of this really translates to jobs or economy, whether it's fisheries, tourism, or recreation. There is a number of jobs that are directly tied to our coral reefs and really are the backbone of our economy when we're talking about South Florida. So in combination, that is a lot of dough. In fact, Florida's coral reef here in South Florida is estimated to provide $2 billion in goods and services every year, every single year. So that's an incredibly valuable resource and ecosystem that we need to properly conserve, manage, and restore with all of these things in mind. But we should take a small step back, right? I want you all to understand specifically what is a coral reef, right? It's generally thrown around a good amount, but I feel like some people don't understand what they actually are composed of. So the best way to think of this is building blocks like Legos or bricks, where all the individual pieces build up the actual structure. So let's look at that when it comes to a coral reef or coral colony. So if we zoom up on an individual coral colony, it looks like this, right? So you can see these individual circles or coral polyps, which is the animal that makes up the entire structure. So if we pan out a little, this is what a coral colony looks like. So that's a single coral colony with all of those individual coral polyps making up that one coral colony. So if we pan out even further, then that's a coral reef. So a coral reef is composed of multiple different coral species and colonies that together build this 3D structure that we call a reef. Right? So they really are the physical building blocks of the ecosystem as a whole. And they're very simple organisms called colonial organisms because they are made of hundreds, if not hundreds of millions of polyps and closely related to the jellyfish. So a good way to think of this is like a city, where a city is composed of multiple structures that support all the things that live there. But individually, they are unique cells, right? So if you think of someone in an apartment building of a skyriser, each individual apartment unit is a piece or coral polyp of that overall colony. So let's take an underwater look at what some of those coral species are. So you can see some branching corals on the top, a star coral in the bottom left, and a brain coral in the bottom right. This is just to show that a lot of different types of corals build up a coral reef, especially here in South Florida. But for the focus of this talk, we'll be primarily talking about staghorn coral. So let's take a look a little bit closer at that exact species. So if we zoom in, once again, you can see those individual coral polyps that I've been talking about that build up that overall branching structure. But if we zoom in a bit further on that one individual coral polyp, it looks like this. So this is a cross section of a coral polyp, the animal, and you'll see that it has tentacles. The red is kind of its filamentous stomach cavity. It has a mouth that it can consume food. And then that white lattice structure is the skeleton. So over time, the coral will build this skeleton as it grows, which is essentially how you see the structure, the colony actually get bigger over time, is the coral polyp laying down layers and layers of skeleton. But what makes corals really unique is that image in the top right. So we zoomed in on just one tentacle of the coral polyp, and there you can see all those orange dots, which are the symbionts that live within the coral's tissue, called zooxanthellae. It's actually a type of plant, an algal plant that lives inside the coral tissue, and in exchange provides the coral with majority of its energy. So it's a symbiotic relationship where it has a home inside the coral, and in return, the coral actually benefits by having this energy source, because the coral symbiont, the zooxanthellae, can turn the sun's light into energy. So it makes it kind of this unique three-headed monster, where you have the coral polyp, which is the animal, you have this algae or plant living within the coral's tissue, but together they're building this coral skeleton, right? The actual structure that makes up a reef. So it's kind of a combo of all three things. And this is really impressive when you think of the fact that coral reefs can be seen from outer space. So they're these huge ecosystems supporting millions of organisms that are built by these tiny little individual polyps and their algal symbionts. So that's where I circle back, talking about these rainforests of the sea and how special these ecosystems are. But I'm obviously here today talking to you because there's a problem, right? This is no longer the norm. I took this photo myself in Biscayne National Park in South Florida here of a beautiful, thriving coral reef. But this image always sticks with me because of how rare it is to find in today's offshore ecosystems. In fact, this is more likely the coral reef that you'll find offshore Miami, Florida. So you can see it looks a lot different. It's flat and barren, lacks diversity and overall life. And this is the current state of our coral reefs. In fact, back in 2003, they had already reported a massive decline in corals by 80%, to where just a fraction of our reefs are actually covered by living coral. And so here you can see they had said down from 50% to 10. We would estimate that's closer to 3 to 5% now. So we're at risk of losing our coral reefs in our lifetime, meaning all of those associated benefits that I listed earlier. And this is such a problem because while corals are the literal building block of reefs, they're also the figurative one, meaning that if we lose our coral reefs, we worry there will be a domino effect that ripples all through our oceans, as well as the communities that depend on them. So it's critical that we don't let that happen. So let's talk about some of the threats. How did we get here? Well, one of the first ones is coastal development. As we continue to build and build in our coastlines, that either directly or indirectly disrupts these ecosystems through dredging, runoff, sedimentation. A number of these can have impacts on our corals that's causing habitat loss. Next is overfishing. As populations and pressure grow, we're seeing these scales tipped in the wrong direction, where these ecosystems are out of balance, and we're overharvesting at an unsustainable rate that causes an overall negative impact on our corals. Next is water pollution that can be correlated with disease. So corals can get sick just like you and I. In fact, there is an outbreak called stony coral tissue loss disease currently impacting our reefs, dating back to 2014, and has caused dramatic declines that we believe is from dredging and the unearthal of some harmful bacteria. And so we need to consider how our water pollution and development is impacting corals when it comes to disease. And then last but certainly not least is our changing climate. So we're seeing increased ocean temperatures as well as increased ocean acidity, which are both having very negative impacts on our coral reefs. So as you can see, many of these are largely human-induced stressors and kind of complex in how they're related. So there is no one silver bullet on how to restore our coral reefs. It's going to take a combination of things in addressing these various threats. Very briefly, I want to talk a little bit more about coral bleaching, which many scientists consider to be the #1 issue facing our coral reefs and are largely caused by rising ocean temperatures. They have this phenomenon where you have these healthy coral reefs in the far left, then these increased ocean temperatures cause the corals to bleach, which is essentially them kicking out that algal symbiont. putting them at risk of mortality. And so on the far right panel, you can actually see this beautiful, healthy reef died in a matter of weeks because of this bleaching event. And we're seeing them happen more often and more severe. So if you'd like to learn more about this, there's an amazing documentary called Chasing Coral on Netflix that you can stream anytime that I would highly encourage for those interested. So the final depressing slide of the day is, where are we at now? Well, all of these stressors have caused massive losses in our keystone coral species, those that are foundational to building this structure, to the point that several are actually listed as threatened under the Endangered Species Act. A third of all coral species worldwide are considered at risk of extinction, like the dinosaurs, and 75% of the coral reefs around the globe are considered highly threatened. So these are serious issues that are in our lifetime, not the next, meaning that we need to address them. But the good news is that something called reef restoration can actually work to recover these degraded populations. So that will be kind of the focus of this talk moving forward. So let's talk specifically about what we are doing here at the University of Miami's Rosenstiel School. Well, it's called coral reef restoration and dates back to about 2009, where Dr. Diego Lehrman first started this research and restoration activities in our lab to figure out how best to grow these corals and then restore them back onto the reef. And honestly, it's pretty straightforward, where there's essentially only 4 steps, where first you have to collect small pieces of coral from the wild. These are called donor colonies. So you find healthy colonies that can be parents, you collect a small fragment from those, and then you move them to an underwater nursery or safe haven where we know that they're going to thrive. So once you have them there, you grow them or farm them, largely called coral gardening for a reason. So as these corals grow, you will then be able to propagate them, which is just a fancy word for replicate or fragment, into additional colonies or pieces. And the reason this works so beautifully is because when these corals grow and then you fragment or propagate them, they'll actually respond positively, meaning that they will not only heal, but grow faster because of it. It's called pruning vigor, and I'm told it's a lot like gardening rose bushes. So as you cultivate or propagate, you're going to increase the number of corals that you actually have. So that allowed us to grow exponentially, so that we turned 100 donor corals into 200, into 400, into 4,000 relatively quickly through this process. And then last, we actually transplant them back onto local reefs where they belong to promote both population recovery and reef function. It's scaled up in the last 10 years quite substantially, to the point that tens of thousands of corals are being outplanted all the time, making meaningful difference on our reef ecosystems. So let's take an underwater look at this real quick. First is the grow out phase. So on the left, you can see pieces of staghorn coral that we housed on what we call pedestals. And then on the right is 1 year later. So you can see these corals really flourish. They blossom. They had all new branches in all different directions. So at that point, we can then propagate or collect pieces from that new growth to put on additional structures in our nursery. So here you can see what we call coral trees that are all hanging staghorn coral, a lot like ornaments. And so we'll continue to grow and propagate until we have a sustainable stock in our nursery. At that point, we then plant them back onto the reef. So here you can see one small piece of staghorn coral that we fixed to the reef with nail, cable tie, and epoxy. And then 1 year later, a new, or the same coral, but large and mature and contributing to that ecosystem. And then when you scale that up to thousands per year, then you're building reef, right? So this is a sustainable population that can support itself, reproduce, seed the surrounding area, so that we don't have to continually intervene in that activity. But I wanted to really drive this across because it's kind of a special process. So here are small pieces of staghorn coral about the size of an index finger. 8 months later, you can see they start to grow branches and blossom once again. We then went in and fragmented off the top of that coral so that they were the same size as when we initially planted them. And then in the same amount of time, you can see there's more growth. So that's that pruning vigor I talked about and makes this whole process possible, or the whole process possible. The other important thing with this is that it's low tech, right? We wanted to ensure that to do this, it didn't require a substantial amount of resources. So here you can see that these corals and gardens can be set up on lines or blocks, trees, frames, or tables. While we primarily use the coral trees here in South Florida, around the world, they might not have access to those same materials. So it was critical that these techniques and tools could be transferable really anywhere, and it showed that they are. So here's a snapshot of our team to date, right? You can see the map on the right marking the University of Miami's Rosenstiel School, and then the 3 yellow stars showing where our underwater coral nurseries are. And they span pretty much all of Miami-Dade County, which is depicted here in the graph. And then all of those dots are either our research or citizen science restoration sites. So again, you can see we're essentially filling in all the gaps along Florida's coral reef to increase connectivity and promote that natural recovery. In fact, to date, we have over 100 different restoration sites and have outplanted over 40,000 corals back onto local reefs. Many of those corals are actually in the past 3 to 4 years alone. Really shows how much we've scaled these processes. So now I want to quickly recap the successes of coral restoration as a whole. What have we really achieved in the past decade? Well, first, we were able to establish that the mean survival of our staghorn coral outplants exceeded our benchmarks. We had hoped that 80+% of all of our outplants survived to maturity. And when pooled across regions, both here and in the Caribbean, we saw that it was actually 85%. So those are really strong numbers for these coral outplants. But we realized that as the problems facing our coral reefs became more pressing, we couldn't just focus on a few individual species. We needed to think of the ecosystem as a whole. So we worked aggressively to incorporate different coral species like brain and star corals so that we're restoring these reef sites. They're more diverse, robust, complex, and can actually replicate the full ecosystem function that a reef is supposed to do. But we realized that these corals may still succumb to some of the same stressors that I outlined earlier. So we collaborate with other researchers like Dr. Andrew Baker here at the University of Miami's Rosenstiel School to do things such as stress hardening to help make corals more resilient in the face of these ongoing impacts. So one example is that if corals are exposed to increased light or temperature, they will bleach, coral bleaching. But if you allow them to then recover in a safe space, they may become more resilient because of it and less prone to coral bleaching in the future. So simple tools like this that occur naturally in the wild can be integrated into reef restoration to increase our success in the face of our changing climate. Lastly, we wanted to see that our restored populations were successfully reproducing, right? Were they spawning and producing viable offspring? And in the summer of 2020, we were ecstatic to see that our coral nursery and restoration sites were proud parents. This spawning was a successful event where we were able to fertilize staghorn coral babies that were viable and now are actually in our own nurseries, continue to be gardened with brand new genotypes that could be more resistant to some of these same impacts. An important step for reef restoration as a whole. Lastly, in collaboration with a number of different groups, we launched the Southeast Florida Coral Reef Restoration Hub, realizing that we could no longer work in individual silos, but we instead had to band together with some of the best and brightest coral scientists in the area to use all these different tools and techniques in combination so that when we were restoring sites, they were fully functional with all of the best strategies that we currently had available to really give us a blueprint for reef restoration around the world. So I would encourage you to look up the Restoration Hub if interested in learning more about that project. So the future of coral reefs, what will it really be determined by? Well, it'll be 3 things. First is the organismal response, or the coral. Next is the ocean atmosphere response. But perhaps most importantly is us, society's response. Knowing how important corals are and the dire state that they're currently in, what are we actually going to do about it? You know, what are we going to do to ensure we don't lose them in our lifetime? And so it was at this point that Dr. Learman realized that our lab could do more, right? We had a platform that was capable of engaging individuals and making a difference in our community. And so we decided to use citizen science as a way to better connect with society so they can be a part of these solutions. For those unfamiliar, citizen science is exactly as it sounds, where it's any individual from the general public teaming up with scientists for some research project with the goal of both educating and engaging them in that activity to both help with the project, but raise awareness and action for its importance. So for us, that is called Rescue a Reef. That is the program that I manage, an extension of our coral restoration lab, and will be the final portion of this talk. So Rescue a Reef was established in 2015. with the goal of building both community and coastal resilience through our coral reef research, restoration, and of course, citizen science. The reason being is we felt that there was a disconnect where the information that we were learning wasn't actually getting to the general public. So by creating the citizen science program for individuals to learn and participate and stay in touch with, we hope to rebuild that bridge so that science and society are once again hand in hand, and that we are able to reclaim better ownership over these amazing resources and ensure their future. So what does Rescue Reef really look like? Well, we built what we called expeditions, these citizen science field expeditions that are led by our researchers, staff, and students, so that any individual, diver or snorkeler, has a chance to actually come on the boat with us, learn about our research, the tools and techniques to be coral gardeners, and then actually help. So they come offshore for a half day as the citizen scientists to directly contribute to our restoration efforts. So let's take a look at what that entails. We start the day either in the morning or afternoon with a short overview and orientation of what it is our program is and what we do, before then teaching the methodologies of coral gardening and active reef restoration, before heading offshore to our underwater coral nursery. So here again on the right, you can see one of our coral trees with all these staghorn corals housed, where individuals will actually help complete some maintenance. So here you can see that they will help clean our trees with some regular TLC. They'll take some measurements, and then they'll actually harvest the corals that we'll be planting that day. So once we have a few hundred of these threatened coral species, we'll then bring them back up to the boat to transport in coolers. At that point, we'll then head to a local reef restoration site where we will work to actually transplant these corals back onto the reef. So we've actually made a switch very recently to where we work with cement. It was empirically tested in our lab and offshore to be coral and user friendly. And then the cement is transferred to piping bags. So as you can see on the right, we simply put a small dollop of this cement on the reef floor, attach the new piece of coral directly to it, and then about an hour later, that coral is securely attached to the reef and will start growing as little as a day. So here is a photo of small pieces of staghorn coral that we had outplanted in a cluster via cement. And then 6 months later, you can see those corals are happy, healthy, and growing in all directions. And we've been pretty busy. Rescue Reef was established in 2015. Over that time, we've established 10 new restoration sites for our citizen scientists. We've hosted over 80 different expeditions. In fact, we just broke 1,000 citizen scientists, an incredible milestone for our program. And these individuals, these community members, have actually outplanted over 8,000 corals back onto Florida's coral reef, which is just tremendous when you really think about it. So now I wanted to circle back to that kind of depressing photo I showed you that is the current state of our coral reefs. But this is a success story. A keen eye might have noticed that this is actually one of our restoration sites that Rescue Reef worked to restore, and that there are small staghorn corals kind of speckled along the benthic habitat. And so then 1 year later, this site transformed into the reef you see in front of you. So it is coral reefs for the people, by the people. And that's really what's so impactful about our program, is that this is for the general public to learn about these resources and be a part of their recovery. So now I wanted to pivot to all of you, all of our audience members here this evening, to talk about what specifically you can do in your everyday lives to support Rescue Reef and coral conservation as a whole. So first, let's just start with do something. And I like to underline an emphasis and exclamation point this, because I commonly hear people say that they're just one person, we can't make an impact, our everyday lives, are minuscule compared to the big picture. And with that mindset, yeah, you're likely right, because if millions of people are thinking that same way, that's the issue, is assuming someone else is going to figure out how to solve these issues. But it has to start with us. So do something, right? We're all unique. We have unique spaces that we work in, skill sets that we've honed. And so if you leverage that for coral conservation, it really can move the needle. But then looking at some of the simpler things, the low-hanging fruit on how you can be more eco-friendly and coral conservation, here's a short list that I put together. So reduce, reuse, recycle isn't new to really anyone at this point, but I underline reduce because that's where you can have the most impact. Simply reducing your reliance on, these single-use items like water bottles or grocery bags has the biggest impact, and instead pivoting to reusable water bottles, reusable Tupperware, reusable grocery bags, that's where we actually see the lessening of our impact and reliance on our coral reefs. Then looking at, okay, how can we put our dollar to work? Well, that's thinking about who you're actually purchasing. What brands are you supporting? So if you prioritize, purchasing eco-friendly brands that prioritize sustainability, that can have a role. And I promise you that they pay attention to those things. How we choose to spend our hard-earned dollar does make a difference. So thinking about how you're actually shopping can make a difference for coral reefs. Next is food waste. I don't think many people realize this, but up to 40% of food waste as a whole is at the individual level. So in our own refrigerators, and that has a huge impact on our environment and is very wasteful. So simply reducing food waste actually has a huge role in conservation, especially for coral reefs. Then talking about it. I feel like there's some stigma about talking about conservation or sustainability or our future. But you all are so important on this front because I can only give so many presentations. And when I do, I'm a biased individual, right? I'm a coral scientist. So if they hear it from you, it's going to have much more of an impact than if they hear it from me. So I'd really encourage you, if you're passionate about this, believe it's important for our future, to talk about it. Because the more we do, the more it becomes norm, and the more we're going to see change at the societal and political level. But last and perhaps most fun is diving in, right? So our program was built to have individuals like yourself on the boat with us. And so we pride ourselves in our ability to continually host these public expeditions that are more affordable and accessible to any individual who's interested. So I would encourage you to check out Rescue a Reef if you haven't already, and stay tuned for a public expedition. If you're not able to come on the boat with us though, we are always looking for additional people that can support us. All donations go directly toward outreach events, supplies, and our coral restoration expeditions. So we greatly appreciate each and every single dollar that you all donate. If you're looking to learn even more about our project and hear about our story, we were actually very fortunate to be a part of a documentary called 100 Yards of Hope, where we teamed up with Force Blue, a group of US retired combat veterans, special operation veterans, and NFL Green, the sustainability branch of the National Football League, to launch a football field-sized restoration effort. So very briefly, I wanted to show you all. Our Florida's coral reef has seen dramatic decline to the point that our reefs are on the precipice of disappearing.
If you live in Nebraska, the middle of the country, how is coral reefs important to you? We get that question all the time. Coral reefs are the breeding ground of all the other species that live in the ocean. If we don't protect the ocean, we won't have a world where we can breathe healthy air.
There's a lot of bad news when we talk about coral reefs, but there's also a lot of hope. Innovations and new tools and new ideas shine some light on the potential for us to restore these delicate reef systems.
We were really the first people to be able to predictably spawn corals in a biosecure facility, and we can do it in a way where they can be planted back out onto the reefs again. So how do we make restoration and outplanting really efficient?
Force Blue retrains and then redeploys former special operations veterans, all military trained combat divers, to work alongside environmentalists and marine scientists on ocean conservation missions.
It's a challenge for many veterans to go from that really defined sense of mission and then trying to figure out who you are and what you're supposed to do as a civilian.
I fell apart after the Iraq War. That darkness, that shadow, it started tearing me apart. The Waters of Life from Force Blue completely healed that.
The bulk of their underwater work had been in the dark, in kind of murky areas. They never looked around, and now they're getting back in the water, amazed at the biodiversity and how therapeutic it is to have a different mission.
Innovation happens when challenges present themselves. Big solutions require collaborative conservation. Everybody is coming together for 100 Yards of Hope.
By connecting this coral reef project to Super Bowl, we hope it will bring much wider attention to the plight of coral and to our oceans. 70% of people pay attention to sports news, sports headlines. Only 15% of people pay attention to science.
We're at the restoration site, so we've arranged the plot to look like a football field. So each buddy group is actually going to take one of the yard lines to build the perimeter of the field.
Most of the things that I've done have been more on the demolition side, so this is pretty neat in the restoration side. People that have experienced trauma and pain want to protect things that cannot protect themselves. We have to heal others or other things to heal ourselves.
While our time is dwindling, the fight's not over. Right now, we have the world's attention. All eyes are on Florida. This really is ground zero. If there's anywhere to fight for their future, it's here. So coming soon is no longer coming soon. It's out. You can stream this anytime you want at floridascoralreef.org/100 yards of hope. But if you simply Google 100 yards of hope, you can find it quite easily. So I'd encourage you to tune in if interested. At that, I want to acknowledge our proud sponsors that have supported Rescue Reef and our coral research and restoration over the years. This work and this presentation wouldn't be possible without their enthusiasm, support, and trust in our activities. Before opening up to questions, I will try and reach as many that I can, but if I'm not able to address them all, please don't hesitate to reach out. We're on social media, all the major platforms. You can see our email there, as well as our website to learn more.